Okay, so next coming to a very important topic, the scales of pressure measurement. Okay, so now what are the scales of pressure measurement? So we know one thing, that we are constantly living under atmospheric pressure. We are constantly surrounded by the air around us. Around 64 kilometer of air is surrounding us, and because of that air we are constantly living under a pressure. That pressure is called as the atmospheric pressure. और उस एटमॉस्फेरिक प्रेशर की वैल्यू भी हमको पता है, डेट एटमॉस्फेरिक प्रेशर इज 1.01325 बार. दिस इज अवर एटमॉस्फेरिक प्रेशर. ओके, so suppose I am taking the atmospheric pressure in one line. This is suppose P atmosphere which is 1.01325 bar. अगर मैं इस atmospheric pressure के नीचे जाता हूँ, the pressure will decrease and at a point I will get 0 atmospheric pressure. That means pressure is equal to 0 bar. ओके, 0 बार प्रेशर हमको जहां पर मिलेगा, डेट पॉइंट इज कॉल्ड एज द एब्सोल्यूट जीरो प्रेशर. getting this not? Okay, if I am decreasing the pressure below atmospheric pressure, at a point I will get pressure as 0 bar. This pressure is called as the absolute zero pressure. And if I am measuring the pressure with respect to this absolute zero pressure, डेड प्रेशर इज कॉल्ड एज द एब्सोल्यूट प्रेशर. अगर मैं इस एब्सोल्यूट जीरो प्रेशर के रेफरेंस से कोई प्रेशर मेजर कर रहा हूँ, सपोज आई एम मेजरिंग दिस फ्रॉम हियर, सो दिस प्रेशर विल बी कॉल्ड एज द एब्सोल्यूट प्रेशर. गेटिंग दिस? एंड इफ आई एम मेजरिंग दिस with respect to atmosphere, if I am taking the atmospheric pressure as reference, as datum, और इसके reference में अगर मैं pressure measure कर रहा हूँ, this pressure is called as the gauge pressure. Getting this on? Okay, and this P atmospheric pressure as we know is what? 760 mm of Hg, and this 760 mm of Hg is nothing but 1.01325 bar. Okay, so this atmospheric pressure is 760 mm of Hg. So suppose if the pressure given is, suppose absolute pressure given है, suppose that is around 860 mm of Hg. Okay, absolute pressure is 860 mm of Hg. What will be the gauge pressure now? So 860 mm of Hg, that means this will lie above this. This is nothing but 860 mm of Hg. This is suppose 860 mm of Hg. Okay, this is the absolute pressure. This will be absolute pressure. If I want to measure the same pressure in terms of gauge, so gauge pressure क्या हो जाएगा? This distance, which is nothing but 860 minus 760, which is equal to 100 mm of Hg. As simple as that. That means above, इस पॉइंट के ऊपर जब हम मेजर कर रहे हैं, that is gauge pressure, और इस पॉइंट से अगर हम नीचे मेजर करें, then this will become vacuum pressure. Getting this? For example, suppose the example is given, suppose the vacuum pressure at a certain point is given as 200 mm of Hg. Then what will be the absolute pressure? Okay, vacuum pressure 200 mm of Hg है, that means 200 mm of Hg from this point. From this point we are getting 200 mm of Hg. This is given as suppose 200 mm of Hg. Okay, atmospheric pressure के नीचे 200 mm. Okay, so if I want to measure the absolute pressure, just measure it from absolute zero scale. So this absolute pressure will be equal to total, this is 760 minus 200, which is equal to 560 mm of Hg. Very simple to determine. Okay, so at any point the bottom line is that if we are measuring this, so atmospheric pressure is actually the zero gauge pressure. Atmospheric pressure will be considered as zero gauge pressure. In terms of absolute pressure, atmospheric pressure is 760 mm of Hg और 1.01325 बार. अगर हम atmospheric pressure को datum लेके चल रहे हैं, so above atmospheric pressure it is called as gauge pressure, below atmospheric pressure it is called as the vacuum pressure. Getting this? Okay, so you can write certain note here. First thing, the pressure cannot be less than the absolute zero pressure. This pressure cannot be less than absolute zero pressure. That means zero pressure के नीचे pressure exist नहीं कर सकता. Zero pressure is the pressure actually at which the molecular momentum becomes zero. Okay, so below zero pressure the pressure cannot exist. This is the lowest point. Next, the local atmospheric pressure is zero at gauge scale. As I told you, the local atmospheric pressure at gauge scale, this atmospheric pressure will be taken as zero. That means P atmosphere vacuum is equal to 0, because this is our datum line. Next, pressure with respect to local atmospheric pressure are called as gauge pressure. If above local atmospheric pressure it is positive, and if below local atmospheric pressure it will be taken as negative. Okay, so above this local atmospheric pressure a positive pressure will be there, below this local atmospheric pressure vacuum pressure or negative pressure is there. Okay, next absolute pressure are measured with respect to absolute zero or complete vacuum. As I told you, absolute pressure is measured with respect to absolute zero. Next note, absolute zero pressure is always positive, and P absolute, total absolute pressure, is equal to local atmospheric pressure plus or minus of gauge pressure. If it is vacuum, then it is gauge pressure. So P absolute is equal to P atmosphere plus minus of P gauge. Getting this? Okay. And standard atmospheric pressure at sea level, atmospheric pressure is 760 mm of Hg, or you can say 76 centimeter of Hg, or you can say 10.3 centimeter of water column. ओके अब ये 76 सेंटीमीटर ऑफ Hg व्हाट इज दिस, ये हम डिस्कस करेंगे अभी. सो इन टर्म्स ऑफ सेंटीमीटर ऑफ Hg द लोकल एटमॉस्फेरिक प्रेशर इज 760 mm ऑफ Hg, और इन टर्म्स ऑफ वाटर कॉलम इट विल बी 10.3 मीटर ऑफ वाटर कॉलम. Getting this or not? Okay, so next is the pressure measuring devices. So the very first device to measure the pressure, or rather I should say to measure the atmospheric pressure, is the barometer. Okay, so this barometer is used to measure atmospheric pressure. So how can we measure atmospheric pressure? By help of using this barometer only. Okay, so we have this beaker in which the mercury is filled. The fluid here is mercury. Okay, and what we are doing is we are taking a tube, we are filling that tube with mercury and inverted that tube onto this beaker. Okay, so what will happen? This mercury will rise up to a certain level. Okay, and above which we will have a vacuum. At this portion we will have the vacuum, and this vacuum is called as the Torricelli vacuum. Okay, now the question arises, how can we measure atmospheric pressure from this? So as I told you that pressure at two different levels, at the same level, the pressure is same. dP by dx is equal to 0. This we have already studied. dP by dx is equal to 0. That means at same level the pressure is same. So if I am taking two different points, suppose this is point A and this is point B. Okay, so at these 2 points, because these 2 points are at same level, so the pressure at these 2 points will be same, and pressure at point A is nothing but atmospheric pressure. Getting this? And pressure at this point, if I want to determine pressure at this point pressure is because of the mercury which is above this. Okay, so this height when measured at atmospheric pressure is 76 centimeter. That's why we call the atmospheric pressure as 76 centimeter of Hg. So what is this 76 centimeter? 76 centimeter is the height, the height which is risen. Getting this or not? Okay, so if I want to calculate this atmospheric pressure, this PA will be equal to PB. Okay, and PA is nothing but atmospheric pressure, and PB, how can we determine this PB from here? So this PB is nothing but the pressure because of the liquid which is up to 76 centimeter above this, and this liquid is nothing but mercury. Okay, now so this will be equal to rho G H for mercury. Okay, and this height for mercury, as I told you, is 76 centimeter. So if I calculate this, so this will be 13,600 into 9.81 into 76 centimeter of Hg, or 0.76 meter of Hg. Okay, so from here this P atmosphere is equal to 101.325 kilopascal. So this is the way how we get the atmospheric pressure, by equating pressure at two different points which are at same level. Okay, so this is how we get the atmospheric pressure. Now one thing I told you students, that we always use mercury in the barometer. Okay, other fluid is not used, or in most of the pressure measuring devices we use mercury. Now what is the reason for that? So first thing I told you was the vapor pressure of the mercury is almost zero. Vapor pressure is negligible. So अगर vapor pressure अगर उसका होता, या or suppose we are using suppose water in which a certain amount of vapor pressure is there, तब क्या होता है? Then at that particular point we would be having PV also here, the vapor pressure. इस point में जहाँ हमको vacuum मिला है, वो point में vacuum ना मिलके हमको certain pressure मिलता, vapor pressure. and then our equation would have been P atmosphere is equal to PV plus rho GH. Okay. Now in this case we will have to measure this PV also, which is not possible. So इसलिए मरकरी यूज़ किया जाता है because the vapor pressure of mercury is almost negligible. So whatever pressure we are getting from this rho GH is nothing but the atmospheric pressure. This is the first reason why mercury is used. Second reason, again I told you that because this P is equal to rho GH, okay, and because the density of mercury is highest, density of mercury is more than most of the liquids. Okay, so because density is high, so the height which is risen by the mercury will be less, will be considerable. अगर मैं यही चीज़ वाटर में यूज़ करता हूँ, ओके, सो सेम चीज़ अगर मैं सपोज मैं वाटर में यूज़ करता हूँ, तो सपोज हमारा प्रेशर है, और प्रेशर इज हाउ मच 101.325 किलो पास्कल. Okay, this will be equal to into 10 raised power 3, this will be equal to rho GH of water. अगर सेम चीज़ हम वाटर में यूज़ करते हैं, so ये एटमॉस्फेरिक प्रेशर तो है हमारे पास, this will be equal to rho GH of water, so this will be 101.325 is equal to rho of water, which is 1000 into 9.81 into height. तो यहाँ से जो हाइट आएगी फॉर वाटर कॉलम, दिस विल बी 10.33 मीटर ऑफ वाटर कॉलम. कैन यू इमेजिन 10.33 मीटर ऑफ वाटर कॉलम, इतनी हाइट की ट्यूब हमको लगेगी, विच इज़ अगेन नॉट पॉसिबल. इतनी हाइट की ट्यूब लेना इज़ नॉट प्रैक्टिकली पॉसिबल. सो दैट इज़ द रीज़न, क्योंकि ये डेंसिटी की वैल्यू जितनी हाई होगी हमारी हाइट उतनी ही कम आएगी. सो द हाइएस्ट डेंसिटी वी नो इज़ फॉर द मरकरी, सो वी यूज मरकरी. सो दीज आर द टू रीजन्स वाई मरकरी इज यूज्ड हियर. Getting this or not? Okay, second device, this is the barometer in which we can measure only atmospheric pressure. Okay, now what if we want to measure some pressure at any point? Okay, so suppose we are having a certain point, and here I want to measure pressure. Suppose P1 pressure I want to measure. Okay, here we are having a fluid at P1 pressure. So what if I want to measure this pressure? Sorry. ओके, सो क्या कर सकते हैं इसमें, बहुत सिंपल वे है. वी कैन पुट अ ट्यूब इन इट. ओके, एंड व्हाट विल हैपन, बिकॉज दिस इज द प्रेशर हियर इज P1 वेयर P1 इज ग्रेटर देन एटमॉस्फेरिक प्रेशर. ओके, सो क्या होगा, इस ट्यूब में ये वाटर लेवल राइज हो जाएगा अप टू अ सर्टेन हाइट. गेटिंग दिस, एंड हाउ कैन वी डिटरमाइन दिस हाइट? दिस हाइट h विल बी इक्वल टू P by rho g, एज आई टोल्ड यू that P is equal to rho gh. Okay, therefore this h height is equal to P by rho g. Okay, so such device is called as piezometer. Okay, so next device is nothing but the piezometer. You can see here. Okay, and what we get in piezometer, we get a height. That height is called as the piezometric height, and as I told you, the value of this piezometric height h is equal to P by rho g. Okay, so if we want to determine the pressure at any particular point, okay, we can use this piezometer, and this piezometer is used generally to measure low pressure. This is not used for very high pressures, moderate value. So this piezometer is used for measuring pressure of moderate values. Getting this or not? Okay, another such device which is used to measure pressure at a particular point is simple U-tube manometer. Okay, so what we are doing in the simple manometer, suppose this is the pressure which is to be measured, P1 pressure is to be measured. So what we are doing is we are connecting a simple U-tube here. Okay, and the manometric fluid here is the mercury. Let's suppose whatever manometric fluid we are having. So what will happen if this P1 is greater than P atmosphere? If this P1 is greater than P atmosphere, initially the level of mercury would be same. Okay, but if the P1 is greater than P atmosphere, then this fluid, whatever fluid we are having at pressure P1, this will push this mercury down. Okay, and the level we will get finally is like this. Getting this not? Suppose this distance from here to this point is y, and this distance is x. Okay, so if we want to determine this P1, pressure P1, so how can we determine this? So same principle we have to use, that the pressure will be same at the same level. Okay, that means we are equating this level. Suppose at this level, so at this level the pressure will be same, so we have to equate the pressure at these levels. So here the pressure here is P1, here the pressure is P1, plus here we are having a certain fluid whose density is rho A, P1 plus rho A G into height is x plus y. Getting this or not? Okay, this should be equal to pressure at this particular point. Okay, so here we are having atmospheric pressure, this is P atmosphere, so this will be equal to P atmosphere plus pressure because of this much fluid, this height is x, so this will be rho B rho g h into g into x. Okay, so from here we can determine the value of this P1, very simple to determine. Okay, this is the case when P1 is greater than P atmosphere. Now what if this P1 is less than P atmosphere? अगर P1 P atmosphere से कम होगा, then obviously this manometric fluid will be up to this level like this. Okay, so this is the second case when P1 is less than P atmosphere. Okay, so because this is a vacuum pressure, so क्या करेगा ये manometric fluid को अपनी तरफ suck करेगा like this. So we will be having the level of manometric fluid like this. This is distance y, this is distance x, and if I want to calculate this P1, here the pressure will be P atmosphere. Okay, so this P1, so this will be P1 plus the pressure because of this y height of rho A fluid, rho A g y. Okay, we are equating the pressure at this particular level. Okay, so up to this point pressure is rho A g y, from this to this point pressure is rho A, sorry, this fluid is having the density rho B g x. Okay, here the density was rho A, here the density is rho B, so this will be rho B g into x, this will be equal to P atmosphere. Getting this or not? Okay, or you can say this P1 will be equal to P atmosphere minus rho A g y minus rho B g x. Getting this or not? That means P1 is equal to, P1 will be less than P atmosphere, and that's what I told you, that this is a vacuum pressure, this is the pressure less than atmospheric pressure. Okay, so this is how we can measure the vacuum pressure or the pressure which is less than atmospheric pressure. Getting this or not? Okay, next type of manometer is the differential U-tube manometer. Differential U-tube manometer. Now from name itself it is clear that, this is used to measure the pressure difference, not just the pressure, but if you want to determine the pressure difference between 2 points, you can use this differential U-tube manometer. So what we are doing here is we are putting a U-tube here at the 2 points, suppose at this point and at this point we want to measure the pressure difference. Here the pressure is P1, here the pressure is P2, we want to determine P1 minus P2. Okay, so here suppose the fluid is flowing, pipe fluid, suppose the water is flowing from here, so suppose the density of water is rho W. Okay, so here we have the water filled. Now here we have the manometric fluid which is mercury in this particular case. So in this, because in this particular case this manometric fluid should be heavier than that of this fluid, so mercury can be used here. So here we have manometric fluid whose density is rho m, and the water flowing, the flowing fluid whose density is rho W. Getting this or not? Okay, the distances are given, this distance is y, this distance is x, we want to determine the pressure difference. Okay, so same thing what we have to do is we will equate the pressure at this particular level, at this level we will equate the pressure at both points. Okay, so at this level the pressure from here, if I want to determine, this will be P1 plus the pressure because of this distance. Getting this or not? And the fluid which is filled in this distance is water, the flowing fluid. Okay, so this will be rho W rho gh g into this distance, total distance, which is x plus y. Getting this or not? Is equal to, okay, now here we have the pressure here is P2 plus the pressure because of this fluid, because of the flowing fluid which is water, plus rho W g, this distance is y, plus the pressure because of this distance, and here the fluid is mercury, manometric fluid, plus rho m g x. Getting this or not? Okay, so from here I can determine P1 minus P2, so this P1 minus P2 will be equal to, so this will be rho m minus rho w into g into x, because this rho w gy will get cancelled out. This will be rho m minus rho w g into x. This is the pressure difference. Getting this or not? And in terms of difference of head, in terms of heads, if I want to calculate, so head h, what is head? P is equal to rho g h. H is head, h is equal to p by rho g. Okay, so if I want to calculate in terms of head, this will be p1 minus p2 by rho g. This should be equal to h1 minus s2, and this will be, if I divide this by rho w into g, okay, so this will be equal to what? This will be rho m by rho w minus 1, g will get cancelled out into x. Okay, so this is in terms of head. h1 minus s2 is equal to rho m by rho w minus 1 into x. Very important. Okay, or you can say this del p, change in pressure, this del p. Okay, so this del p is equal to rho g, rho w g, this is rho w into del h. h1 minus s2 is del h. Okay, this is how we can measure the difference in pressure. If we have the head difference in terms of head, we can calculate the difference in pressure, del p. Getting this on, that means here the del h is differential pressure head in terms of flowing fluid. Differential pressure head in terms of flowing fluid. Getting this on? Okay, now here we have a very important note, that this particular device is used to measure very high temperature, very high pressure difference. This is used to measure high pressure difference, and there are certain conditions for using this type of manometer, and that is, the very first condition is the manometric fluid. The density of manometric fluid should be greater than the density of the flowing fluid. Then only it will settle down. Rho m should be greater than rho w, first thing, and second condition, the two fluids should not intermix. Okay, so दो कंडीशन है. पहली कंडीशन, दैट दिस मैनोमेट्रिक फ्लूइड ऑब्वियसली इससे भारी होनी चाहिए फ्लोइंग फ्लूइड से, डेंसिटी शुड बी ग्रेटर देन दैट ऑफ द डेंसिटी ऑफ फ्लोइंग फ्लूइड, एंड सेकंड थिंग, ऑब्वियसली दिस टू फ्लूइड्स शुड नॉट मिक्स, शुड नॉट intermix. Getting this or not? Okay, next type of manometer is the inverted tube manometer. So this is our inverted tube manometer, and here obviously the fluid, the manometric fluid, the density of manometric fluid should be less than that of the density of flowing fluid. Okay, here we have the flowing fluid with density suppose rho w, manometric fluid is having density rho m. Okay, then only it can float above it. Getting this or not? So okay, so first thing, that the fluid, manometric fluid should be lighter than that of the flowing fluid, first thing. Okay, and second condition, as I told you, the both of the fluids should not intermix, and this is used to measure generally low pressure difference. Okay, previous manometer I told you that was used to measure the high pressure difference. Now this is used to measure low pressure difference with more accuracy. If you want a better accuracy, you can use this, but the limitation is that you can measure low pressure difference only up to for this. Okay, so same thing we will do here. This distance is suppose y. Okay, same thing we will do here, and we have to calculate the pressure difference P1 minus P2. Okay, so this will be P1 minus, at this level we are equating the pressure. Okay, and because this level is above this level, okay, so this pressure will be minus. Okay, so this will be P1 minus this distance, which is rho w g into x plus y, the pressure because of this. Getting this or not? Okay, is equal to here P2 minus the pressure because of this, which is rho w g y, minus pressure because of this, which is rho m g x. Getting this or not? Okay, so from here this P1 minus P2. Now what will be this P1 minus P2 here? So here we have this rho w g y, and this rho w g y, this will get cancelled out, and finally we will have what? Here we will have rho w g x minus rho m g x. or you can say this P1 minus P2 is equal to rho W minus rho M into G into X. Getting this or not? Okay, or in terms of H1 minus H2, so this P1 minus P2 divided by rho WG is equal to H1 minus H2. So this will be equal to, just divide this by rho W into G, so this will be 1 minus rho M by rho W into G will be cancelled out into X. Okay, so this is the expression for pressure difference in terms of head, H1 minus H2. Getting this or not?